Welcome to Brain Vision.
These are the two force diagrams for our two blocks. For the block moving horizontally, there's a tension force T1 to the right. There's gravity pulling it down and a normal force up. In the second block, there is a tension force, not necessarily the same as this tension force, pulling it up, and then gravity pulling it down. And so if we apply Newton's second law in the x direction for this one, we get this. And then the only force in the x direction is T1. And so we get that. So the coordinate system in this problem will be this. It'll be positive x to the right and positive y downward. Now, if we do Newton's second law for this block in the y direction, we get sum of the forces in the y is equal to mass times acceleration in the y. That leads to m2g minus t2 is equal to m2a2. And so I'm going to go ahead and circle these equations here. They're not the final answer. They'll just be really important later on. You'll notice we want to solve for a2 and a1. Actually, I should have substituted in here. This isn't ax anymore. This will be a1. So there's an acceleration a1 there and an acceleration downward a2 there. But we have four unknowns in this. We have a1, a2, t1, and t2. They're all unknowns. So we need four equations to solve for them, and we only have two equations. So clearly we need some more equations. They come from a different force diagram, this time for the pulley itself. And so for the pulley, we're going to have T1 upwards. We're going to have another T1 upwards. I draw two dots here. Really, they should be the same dot. It's just hard to draw two arrows going the same direction from the same dot. There's going to be a force mg downward. I'm calling the mass of the pulley m. There's also going to be another force, T2 downward. And the overall acceleration is downward. And so sum of the forces in the y direction for the pulley here is equal to the mass times the acceleration of the pulley. This leads to mg plus T2 minus 2T1 is equal to mass times acceleration. But we're assuming that the pulley's mass is negligible. So that goes to 0, and that goes to 0 too. And we get T2 is equal to 2T1. That's one of the equations, but we still need one more equation in order to really solve for all our unknowns. The other equation will come in the form of the accelerations being related. We know the accelerations of the two blocks must be related because they move in unison, but they don't move exactly together. Because mass 2 is on a pulley, it actually turns out that if mass 1 moves a distance d, say, then m2 moves d over 2 because m2 is attached to a pulley and you need to move double the distance in order to move that same distance in m1. And so because we have this relationship here, we know that the acceleration of block 1 is equal to 2 times the acceleration of block 2. And that's the fourth equation we need. And so at this point, you could solve it. It's a system of equations at this point. But the way you would do it is you would first take this equation here and substitute in that T2 is 2T1. So you substitute and you get 2T1. And then you'll substitute this in for that T1. Whenever you do that, you get, let me do it on a separate page here. You do the steps I just mentioned, and you get m2g minus 2m1a1 is equal to m2a2. And then at this point, you're going to use, again, that a1 is equal to 2a2. And you're going to plug this in here and then solve for what a2 is. When you do that, you get that a2 is equal to m2g over 4m1 plus m2. And that's half the answer. The other half, it wants a1. But a1 is 2a2. So we just put a 2 here. 2m2g over 4m1 plus m2. And that completes the answer.